Sponsored by Air Acuity, creating measurable better environments.
Without further ado, I want to bring on Tom and Tom. Please show yourselves.
Hi, everybody. Thanks for coming.
Good afternoon.
Gentlemen, I am going to hand over the mic to you. You should be able to, oh, you know what? I wanted to remind everybody, all of the attendees, you can go ahead and if you guys have any questions or any comments, go ahead and use the icons below. You should see those. And I'll make sure one of the guys can see the questions, and if not, I'll go ahead and interject and let them know you have a question. But guys, I'll hand you the mic.
Thank you. I guess I get to start. Going to share this screen to begin with. Hopefully all of you can see this.
There it is.
Right. What I'd like to do is get rid of that. Okay. First of all, thanks to Anastasia and High Profile for the opportunity to speak to you all. And thanks very much to Nicole Peterson in our office, whose tireless energy continues to go a long way to raising FlowTech's profile in the architectural, engineering, and construction community. We are a rep firm, yes, and we do our best also to be considerate of all of the factors affecting occupants in the built environment, and try not to be, for lack of a better term, ambulance chasers. That said, please allow for the shameless plug for Air Acuity, and as Anastasia said, they helped us sponsor today. So you will, we did try to sanitize this as much as possible, but you will hear some brand specific stuff today that can't be avoided. This is who we are, and this is what we do for FlowTech, which is a company of many products, all of which go to Airside, typically energy savings or air quality or airflow improvement. I don't show this as part of the shameless plug, but to give you consideration for our experience in the built environment with managing and controlling and measuring airflow and air quality. Again, we tried to brand sanitize this as much as possible, but we're hoping to leverage our years of experience with safe, smart ventilation products and practices to offer some guidance to the building design and improvements going forward. So these are what we're going to talk about today, the historical challenges, both with viral contagions and with Airside products and designs, what the path forward looks like, and what post-COVID-19 healthy building considerations should be. All of this is framed within the context of, if you don't measure, you can't manage, you can't control, and you can't improve, which means for all intents and purposes, you lose money. So that in mind, talk a little bit about the history. When I started in this business, many products were coming into the market as a reaction to Legionella, which is probably the most recent pandemic that we can consider. And since tuberculosis, since tuberculosis was being recognized as a pathogen which could spread via the air. I mean, if you talk to infection control people for years, they said that the only thing that was transmitted in the air was tuberculosis. Everything else was, you know, wash your hands and you're safe. Don't touch this and you're safe. Well, as we're finding out, a great many things, a great many pathogens are airborne, and you can see by some of the criteria from the Legionnaire's disease and Legionella that the one we're dealing with today, the COVID-19, is very familiar. It has some of the same properties. So some obvious challenges then with delivering optimal values for each of these parameters. Relative humidity, measurement and control, economizer control, ventilation. Some of these terms are going to be foreign to many of you who are not specifically involved in HVAC. And Tom will talk a little bit more in detail about some of the technical aspects of this. Sorry, I'm going to move that off that screen. Thank you. And sorry. Some obvious challenges, obviously, in delivering optimal values for each of these parameters, but also significant improvements over the last 20 years for each of these. We've seen a lot of industry improvement for all of these type procedures. We know we can and will return to better buildings. We have a pretty good head start. We've worked specifically for years in critical environments. Like bioscience labs, healthcare facilities, to make them safer. So it's not too big a stretch to extend that to all buildings, including residential. And we need to consider all building environments as critical environments for both new and retrofits to existing buildings. That sounds expensive, but what is the real cost of getting back to work? What's the real cost of getting back to school? What's the real cost of being able to find entertainment in sporting venues and the real cost of well building? So we know that healthy buildings are achievable. We've been working toward that goal for many years with many people in the lab and healthcare and bioscience space. We think that can translate to all buildings. So the movement, the good news is the movement has been underway for a long time. There's a lot of momentum by virtue of the well building movement and reset, which is very similar to well in terms of the air components of healthy buildings. Reset tends to be more common in Southeast Asia. And there's a lot of public awareness from people like New England's own Dr. Joe Allen from the Harvard T.H. Chan School of Public Health, who's in great demand these days, but he's in demand because he's worked extensively in this field for some time. Some of you may be aware his group is responsible for the significant amount of data they acquired in multiple iterations of their COG-FX study and essentially proved that the quality of indoor air is directly related to human cognitive function. And if you Google COG-FX, you'll see a great many links and a lot of information about their findings with that study. More recently, we're seeing in leading publications these concepts being talked about, articles being written, and how building design and operation changes can not only make you sick, but also make you well. And again, this article by Dr. Joe Allen in the New York Times, if you haven't seen it, I highly recommend you find it. It's spot on in terms of what buildings have done to us and what buildings can do for us. Along with other recent articles in other publications regarding pandemics, forcing changes in design protocols and design considerations in the business world. These are just a few examples. I know many of you are seeing articles daily. We've collected 20 or so that specifically relate to the HVAC and ventilation aspect of the business. So we did our best to synthesize what are the considerations for healthy and well buildings, as refers to providing for the best environment or the best opportunity for low transmissions of airborne pathogens. At this point, I'm going to hand off to Tom Halgus. He's going to communicate how we're trying to leverage our extended experience with lab buildings, with ORs, with vivariums, or what we call critical environments, so that hopefully we can take those best practices and understand how they might be better utilized in the larger commercial built environment, meaning commercial office, education, entertainment venues, et cetera. So Tom, it's all yours. I'm going to stop share and you can go from here. Thank you.
Thanks, Tom.
Working on it here. Okay, so you should be good. So thank you, Tom, for the handoff, and thank you, Anastasia and High Profile for having us on today. So just picking up from where Tom left off, moving forward, getting people back into buildings, and also for new building design as well. We need to look at some considerations to best reduce the airborne transmission of viruses. Things like particle measurement and control are now becoming a priority. They're more at the forefront of indoor air quality. Dr. Allen's article had mentioned improved filtration can have a big impact on this. Demand-controlled ventilation sequences will provide more ventilation when needed. And also we have to look at relative humidity control. Humidity measurement and control is very important to stop the spread of viruses. And that's also especially important here in New England because we do have the colder months where the air is extremely dry outside. And these lower humidity environments, that's where the viruses tend to thrive. There's other virus mitigations, such as adding UVC lighting in air handling units and ductwork. We'll touch more on that. And now there's going to be increased cleaning protocols in all these workspaces and buildings. As people start coming back, it's going to be more of a continuous function. And what impact are all these different variations in buildings going to have on the HVAC design? There's some changes that are going to have to be looked at there and possibly made. And really, to make sure that all these practices are working, we need to have some sort of intelligence-driven feedback and insight as to what the buildings are actually doing. So we're applying critical environment practices to all the spaces as a key strategy to providing a healthy environment. So going from commercial grade MERV 8 to MERV 11 or 13, it makes a big difference in removing a lot of the smaller respiratory grade particles in a sub 2.5 micron range, and that's the range that we can inhale. They do get into our distal pulmonary alveoli passages. It's a bit of a tongue twister. So the wide belief is that the viruses cling to the small particles, and that's where the airborne transmission stems from. So the key strategy here really is to remove as much of the particulate matter as possible. So how do you know if these filtration methods that people are employing are being effective? So you really should be measuring particles both before and after the filter bag. This validates your filter performance and if your mitigation efforts are actually being achieved. The control sequences for bringing in the outside air need to be looked at. That's why we have to monitor the outside air to make sure that we're not entrailing particles from diesel exhaust from a truck at a loading dock below the air handling unit intake or a fire down the street, et cetera. I mean, we don't want to be bringing these kind of pollutants into our buildings. So monitoring is really going to let us know our filter's effectiveness. It's also going to help scheduling filter changes. It's going to let us know how our filters are doing. On a room level, we believe implementing better control for rooms that maybe have a higher particle generation. We use a multi-parameter demand-controlled ventilation strategy, which increases the ventilation when needed. we reference a room sample to a supply air sample, and that's how we kind of determine what's happening. And all that information gets fed back to the building management system so that things are happening. So you really got to have the feedback with some high particle level alerts, and it's going to verify that the ventilation levels and mitigation efforts are being achieved.
We actually have a question. Can I interject?
Go for it. I'll see if I can answer it.
Where would someone begin if interested in installing a facility monitoring system, and who are the best players to get involved?
The best players is, as far as the location, I would say the facilities management people, possibly environmental health and safety, if it's a science building, and getting involved with it. Really should probably do some research. You can contact us. We will be getting to that point. Yes, we do carry a facility managing system. So basically reaching out to contact Tom Orietti or myself.
Thank you.
Okay. Is that it? We're good? Moving on?
Yes, sorry about that. Yep, thank you.
That's fine. So you can't clean the air with filtration if we don't have enough ventilation and air movement. We do have a history of lab ventilation, and that shows us that ventilation effectiveness is very important to our design and operating consideration. So improved filtration methods, they may have an impact on airflow rates. If so, this is going to need to be taken into design consideration as well. Excuse me. As you go to a MERV 13, et cetera, a higher grade filter, it may reduce the airflow. So that's something that really has to be looked at. And all these airflows, they all need to be validated through diagnostics and fault detection diagnostics to make sure that something isn't working right. So being able to show that the building is balanced and performing as designed, and that the room air change rates are being met. So those are the things that we're looking at with our feedbacks. If there's a high concentration of CO2 for the occupants, increased total volatile organic compounds for cleaning. These are the kind of things that are required to look at to increase the ventilation rates when needed. So the flow feedbacks that we gain from the building management system is going to validate that these goals are actually being achieved. Humidity is another aspect that we have to look at. We need to really have to reliably measure and control for relative humidity. What we've seen is an increased level in RNA virus transmission and disease severity when the relative humidity is low. Optimally, we need to maintain between 40 to 60% relative humidity during peak seasons, which are the colder and drier months. 40 to 60% is the healthy standard for us human beings. Accurate measurement and control of relative humidity is going to yield the most comfortable and the healthiest building results, along with correct functioning airside economizing. Our economizing is based more on enthalpy of the air. So that's it's a little bit different than just going by dry bulb only. It's going to look at your total humidity in the air. So virus and mitigation, other strategies that can be employed. We know that viral and bacterial microbes account for 60 to 80% of the indoor air quality issues. You wind up getting a buildup of biofilms. It happens when mold and bacteria, they adhere to surfaces in a moist environment, and the dust collects on these films. It's going to reduce your system efficiency. It's going to clog your coils, etc. And as the mold and your bacteria spread, your indoor air quality is going to suffer. So we feel that by applying a strategy such as UVC and a 254 nanometer wavelength, that's the most effective and germicidal for killing airborne viruses and bacteria. And that's also going to help in keeping the coils clean in the air handlers if it's employed at the coils. And it's going to make the system more efficient with less drag on the coils. This technology, we use it in ORs, healthcare facilities, et cetera. Can be installed in air handling units at the coil, ductwork. We've also seen it employed as in unoccupied room surface disinfectant protocols, so they can actually turn these lights on, as you can see in that right-hand corner picture there. They actually turn that on in a room when the room is empty to disinfect the room. So we're now looking at enhanced cleaning protocols. Now beyond just an overnight dirt removal scheme, we feel there's going to be more of a constant operation of cleaning in the buildings. This is going to move into cleaning larger areas, disinfecting with stronger chemicals. All this can have a negative effect on the occupants. If you don't have enough ventilation, it can give them headaches, can smell, etc. And this all comes from the increased amount of total volatile organic compounds in the air. So the best strategy, we feel, is to apply a demand-controlled ventilation function using a multi-parameter demand-controlled ventilation. So we look at total volatile organic compounds, CO2 and particle counts in the air, and basically in looking for that, it's going to increase the airflow to a space when an elevated amount of a pollutant is sensed as compared to the supplier going into that space. So it provides a ventilation where and when it's needed. And again, the data needs to be reliable to perform this function effectively. And that's kind of what we do. And this is also very similar to our laboratory demand controlled ventilation events that we've been effectively implementing now across the bioscience and the laboratory market. So design considerations that are changing. We're now looking at 100% outside air systems. They call them DOAS for dedicated outside air system. These are already code requirements in many cities. We're seeing these a lot more now in K through 12 schools and in office buildings. Density considerations are going to be taken into account. As they restructure the workplaces, probably going to see fewer occupants for a given area. Things are going to change around there. Air change rates in these spaces are now being altered. They're being increased to flush the viruses out. And that's where we recommend using a demand-controlled ventilation scheme to intelligently respond to the actual conditions in that space. So really, you're not wasting your energy dollars by flushing in outside air where it's really not needed. And we need to take a deeper view of the air mixing, the supply and return air quality. These both need to be looked at and compared. And again, is the building performing as it's designed? Measurement and validation feedback. It supplies this information by looking at the IAQ parameters. So feedback and insight, we can have it all. In the 1970s, there was a move to close off the outside air intake, and they realized that the indoor air quality suffered. And as part of this, the industry at that time, they had really shifted to a sustainable only and efficiency design only. And now we're looking at decarbonization movements and net zero building design. So going to the other extreme, the healthy building, well movement, their specifications. We're looking at 100% outside air, air handling systems, cleaner air, lower amounts of CO2, no TVOCs or particles. So we've actually found that we can swing that pendulum to the middle and have both efficient and healthy buildings if it's done properly by applying good technologies and the practices. Good reliable data to verify goals are met. You got to have good reliable data. That's really the key takeaway, is having data. Oops.
Quick question.
Go ahead.
How is a person able to demonstrate, like, or I should say, how would I be able to demonstrate building occupants the actual indoor air quality? Like, is Is it practical to implement this type of sensing in small buildings?
Can I handle that one, Tommy?
Go ahead. If you got
Uh,
something off the cuff.
I think the important thing is to start with measurement. You can't tell them what you're not measuring. And once you have the ability to measure it, those are data points. They can be pushed out to an existing web platform on a product like Aircuity, and you can display it for your people. You can set up stations where that's being ported from the building management system out to a display screen somewhere. It can be pushed out via email. Essentially, it's data points, and once you have the data, it can be presented in any way that's kosher for the building owners and the building occupants.
Got it. Thank you.
It's all data. That's why we really stress the gathering of data. So the well movement is certainly evolving to take on all of these new issues. They're issuing particle count and TVOC guidelines that we're seeing recently. ASHRAE's also standing where the transmission through the air is sufficiently likely that airborne exposure of the virus really should be controlled. And the changes to building operations as well. And they're suggesting going to 100% outside air when the conditions allow. The difference is requires ongoing measurement and verification. So you really need to have a system in place that can perform this and keep those systems maintained. Maintaining the systems are going to prevent getting bad data. And Aircuity is basically such a system. So what can be done going forward? Retro commissioning of buildings, going back and assessing the HVAC system that is performing as designed, and can your building operate at 100% outside air and still have the system handle increased heating and cooling loads doing this? You know, you go to extremes during the summer and the winter, you're going to have a bigger load. And how much outside air can be used, and what other devices, ultraviolet, et cetera, really need to be included to help mitigate the airborne pathogens. Retro commissioning, we highly recommend this being done, especially if a building has been shut down for any length of time during the COVID pandemic. So before bringing people back in, you really should have things looked at because, as we say, you can't control what you don't measure. So really specifying a smart and safe facility monitoring system that incorporates TVOC and particle monitoring with the ability to measure feedback and adjust ventilation into new building design, especially with centralized monitoring. It does certainly have some advantages because we see a true differential measurement of TVOCs and particles. These systems, they can be retrofitted into pre-existing buildings. We've seen it done at a core and shell level, looking at the air handlers and just, you know, the individual floor returns. That's certainly a possibility. And it also, it gives us the ability to continuously commission the building by validating that data. All those data points are all saved to a data cloud where the building owner can certainly go to it at any time and trend their building data. And retro commissioning may also show us what other improvements can be made to a building to make things function a little bit better. So that's where I am. We do have a list of resources here. Ooh, Nicole's not here.
I got that for you. I'll go ahead and put that
Got
in.
that for me? Good.
Yep.
I know that she was going to do something with it. She was going to make it accessible to others.
One moment. And we should have this here. There we go. So that should be able to take folks to the FlowTech website, and it actually, that link should open up the PDF with the list of resources that you guys are sharing right now.
Sounds good.
There are a couple of, sorry, you know what?
Can I click on this?
You should be able to, yeah.
Okay. Click on chat.
Yeah, you should be able to click on chat, and it should open up directly to the FlowTech's PDF.
Yeah. Okay. Can I pull this up? There we go.
It does, it works.
Yeah. Okay.
Well done, Anastasia.
No problem. Are you guys okay? It's done. I wasn't sure. I wasn't sure if I was waiting. I wasn't sure if you guys were done.
Yeah, I'm not seeing anything in chat that I need to get back to everybody on. Questions.
I would like to expound a little bit on Tom's retro commissioning point, if that's okay, if we have a few minutes. I think
Sure.
we do.
I think for the most part, a lot of people don't know where to begin. And if you have an existing building and you're facing some changes with that building because tenancy might be changing, people might look at renewing a lease for smaller space, for different space. Without a retro commissioning, you don't know what your baseline is. And the people that do this kind of work, the engineering firms that provide this kind of work, are very good at coming in, establishing what really is happening. Building management systems will give you data points on what they see, but they don't always have good airflow measuring stations, those kinds of things, to really know how much outside air am I currently taking in? How much outside air can my systems handle before we can't heat the air or cool the air enough? Though all of that type of work is very good at establishing a baseline, and the folks in the utility companies sometimes will help you get involved in that process, and maybe even help pay for some of the processes that will improve their energy consumption in making some of those changes. So I encourage you to talk to your representative from your utility companies and/or people you may know in the AEC community that provide commissioning services. All of that, of course, relates to existing buildings.
Awesome. So guys, I heard my echo. There's an echo. Is that me, or is that someone's? Someone actually has. All right. So you guys ready to play Odd Man Out?
Oh, I forgot about that. Go ahead.
No. It's on me, not you. Well, you have to guess the odd man out. So I'm going to make 3 statements about healthy buildings, and it's up to you guys to guess those which one of the 3 statements is the odd man out. Are you ready? Okay.
Go for it.
Sure.
1, buildings can be key promoters of health and well-being since most people spend a majority of their time indoors. 2, according to the National Human Activity Pattern Survey, Americans spend an average of 87% of their time in enclosed buildings and about 6% of their time in enclosed vehicles. 3, healthy buildings encompass a wide range of concepts and applications that promote human health, which include, but are not limited to, site selection and construction, occupation engagement, your mother's television, and personal control. Which one is the odd man out?
Yeah, I don't know, Tom. This is really tough, but I'm thinking maybe 3.
Ding, ding.
The mother's television really threw me off on that.
Yeah, your mom's television is not included in the range of concepts and applications when it comes to healthy buildings.
I thought we were heading down the Yo Mama So Fat jokes there for a while.
Okay. And I just want to give a special shout out one more time. So I'm going to share my screen. Today's webinar is sponsored by Aircuity. They are a hardware and reporting platform that provides the measurement, management, and communication of air quality. We encourage you to visit them at aircuity.com. Really excited that you guys were able to share some knowledge and lay down some tools that people can use on how to measure air quality and what that means and why it's important. I actually had no idea until you guys shared this webinar that, you know, it truly, I mean, it obviously air quality is important for health, lungs wise, but I had no idea that it affected your cognitive ability. So.
Well,
Oh,
for
it
the
does.
longest time, people have used CO2 as a proxy for people in the space and how much ventilation is required. And that ignores a host of other parameters, not the least of which is total volatile organic compounds and particulates in the air. And of course,
Right.
the COVID thing has exposed our lack of knowledge of what kind of particulates in the space.
Yeah. Interesting. Tom and Tom, thank you. Have a wonderful day.
Anastasia, for having us.
Sponsored by Air Acuity, creating measurable, better environments.